Today, we're going to put on our detective hats and dive headfirst into the world of digital forensics. We're talking about how investigators hunt for evidence hidden deep inside two of the most powerful and complex operating systems on the planet, Linux and macOS. So let's get right to it.
It's a pretty interesting question, right? Every single thing you do on a computer leaves behind some kind of trace. For a digital investigator, those little traces are the clues they need to piece together a story, maybe solve a crime, or figure out how a major security breach happened. The real question is, where do they even start looking?
Okay, so before we get any deeper, let's make sure we're all on the same page. Digital forensics isn't just some kind of cool hacking. It's a real science. It's a very methodical process of looking at digital systems, laptops, servers, phones, to find and analyze evidence in a way that'll actually hold up in court or in a company investigation.
The best way to get your head around this whole process is to think of a compromised computer as a digital crime scene. An investigator can't just storm in and start clicking around. Nope. Every single move has to be deliberate, because the #1 rule is to preserve the integrity of the evidence. Now, at this crime scene, investigators are basically hunting for two different kinds of evidence. First, you've got what we can call fleeting digital footprints. This is live data that's here 1 second and could be gone the next. Then you've got the permanent buried clues. This is the stuff that's written to the hard drive and, well, it sticks around. A good investigation has to tackle both.
So, let's start with those fleeting footprints. This part of the investigation is a real race against the clock. It's all about grabbing what's called volatile data, information that only exists while the computer is actually turned on. And why the big rush? Because all of that live data, who's logged in, what programs are running, what network connections are active, it's all living in the computer's memory. It's RAM. The very second you power down or restart that machine, poof, all of that information is gone forever.
What's really fascinating is that for all their differences, these two systems actually share a common language for some of the most basic questions. If an investigator wants to know who's on this machine right now, they use the exact same commands: who, W, and last. It doesn't matter if they're on a Linux server or a brand new MacBook.
On a Linux system, the investigator's toolkit is all about the command line. They'll use netstat to get a map of every single network connection the machine is making. Then they'll use PS to see every single process that's running, even the hidden ones. They'll even check what are called kernel modules with LSMod. Think of these like plugins for the operating system's core, and they're a classic hiding spot for really nasty malware called rootkits, which are designed to give an attacker total hidden control.
Now, over in the Mac world, the goals are pretty much identical, just sometimes with slightly different commands. You've still got netstat and PS doing similar jobs, but here, a tool like macOS Dumps takes things a step further. It creates a complete copy, an image of the system's entire RAM. This basically freezes all that fleeting evidence in time so it can be analyzed in detail later, long after the computer's been shut down.
Okay, so once that live evidence is safely captured, the machine can finally be powered down. Now, the investigation shifts gears into phase 2, digging for those buried clues on the hard drive. This is the non-volatile stuff, the data that actually survives a reboot.
One of the very first places an investigator will look is a clue that both systems share: the command history. It's basically a digital diary of every command a user typed into the terminal. For an investigator, reading this file is like looking right over the user's shoulder, seeing every move they made, which can reveal exactly what they were trying to do.
Let's zoom in on some system-specific clues now. Macs have these things called property lists, or .plist files. You can think of them as the little memory banks for every application. They store everything from the Wi-Fi networks a computer has ever joined to the documents you've recently opened. For an investigator, this is an absolute goldmine of user activity.
And here's a fantastic example of just how specific that evidence can get. Another incredible Mac artifact is its quarantine database. Anytime you download a file from the internet, macOS quietly makes a note of where it came from, the exact URL, and precisely when it was downloaded.
So just think about that. If a piece of malware shows up on a Mac, the investigator doesn't have to just guess how it got there. They can look in the quarantine events database and find the digital smoking gun, the exact link that brought that malicious file onto the system.
Now, shifting back over to Linux, the equivalent treasure trove of information is the /var log directory. This place is like the central nervous system for everything happening on the machine. Files in here will tell you who tried to log in and whether they succeeded or failed. The auth.log tracks security events, while files like WTMP and BTMP are just a meticulous record of every single login attempt. It's a super detailed timeline of who's been accessing the system. Okay, so with all this data collected, both the fleeting footprints and the buried clues, the investigator is now staring at a mountain of raw information. The next big challenge is turning all of that data into actual answers. And for that, they need a very specialized toolkit.
Remember that RAM dump we talked about? Analyzing it is basically a two-step dance. First, you acquire the memory using a tool like Lime for Linux. Second, you feed that memory image into this incredibly powerful framework called Volatility. Volatility can then reconstruct what was happening on the live system, pulling out things like running processes, network connections, and even command line history that was never even written to the disk. It's amazing.
When it comes to analyzing the hard drive image itself, one of the most foundational tools for both Linux and Mac forensics is the SleuthKit, or just TSK. It's really a collection of command line tools that lets an investigator perform a deep tissue massage on a file system.
So what can it actually do? Well, TSK can tear apart a disk image to find things you thought were gone forever. It can actually recover deleted files by piecing them back together from the empty, unallocated space on a drive. It analyzes all the metadata about files, when they were created, modified, last accessed. And for those who aren't huge fans of the command line, it can be paired with a graphical tool called Autopsy to make everything much more visual. And beyond these foundational tools, you've also got the specialists. In the Linux world, a tool like Scalpel is an expert at something called file carving. That means it can find and rebuild files from the raw data on the drive just based on their unique digital signatures, even if all records of the file have been wiped. And on the Mac side, you have entire commercial suites like Macquisition, which are built from the ground up to understand all the unique complexities of Apple's file systems and hardware. So we've collected all the evidence, we've used these incredible tools to analyze it. Now comes the final, and frankly the most important step, putting all of these individual little clues together to build a coherent story. Because that's really what this all comes down to. A single downloaded file, one command typed in the terminal, a weird network connection, a deleted log file. None of these things in isolation tell you a whole lot. But together, they tell a story of exactly what happened, when it happened, and maybe even who was responsible.
So, let's just quickly sum it all up. The whole investigation kicks off with a race against time to capture that fragile, volatile data. And while both systems share some common ground, it's the unique artifacts like Mac'splists and quarantine files that can provide those incredibly specific clues. And of course, none of this would be possible without powerful tools like Volatility and the SleuthKit to turn all that raw data into a story we can actually read.
And that brings us right back to where we started. We've seen the playbook, how investigators can reconstruct events from all this digital evidence. It really makes you think, doesn't it? If someone were to look at your computer's fleeting footprints and buried clues, what story would your digital life tell?